Hi, in this video we are going to see about block diagram reduction techniques. The block represents different components or subsystems and the line shows how signals or information flows between these components. The goal of reduction is to simplify these diagrams. It consists of a single block or a combination of blocks. These are used to represent the control system in pictorial form. A signal into the block represents the input R and a signal out of block represents output C, while the block itself stands for the transfer function. Flow of information is unidirectional, output being equal to input multiplied by the transfer function of the block. It is normally required to reduce multiple blocks into single block, or for convenient understanding it may sometimes require to rearrange the blocks from its original order. And also it is used for the calculation of transfer functions and it's required to be reduced. The basic elements of block diagram is the summing point, takeoff point, and the transfer functions input R and output R of S, a feedback path. A block diagram is basically modeling of any simple or complex system. It consists of multiple blocks connected together to represent a system to explain how it is functioning. The transfer function is the ratio between transformation of output to the transformation of input when all the initial conditions are 0. This block diagram shows an example of a control system. So these are some of the basic elements of block diagram. The rules for block diagram reduction techniques is given in this slide. So first one is the combining blocks in cascade. So original diagram we are having G1 and G2 in series. The equivalent diagram is combined into a single block with G1, G2 as transfer function. So parallel blocks are combining. In this we are getting the output as G1 plus G2. So third rule is moving a branch point ahead of the block. So while moving a branch point ahead of the block, the transfer function is added as 1 by G1. Moving a branch point before the block, in this G1 is added with addition to the transfer function G1. If we are moving the summing point ahead of the block, we again add a transfer function G. While moving the summing point before the block, we added 1 by G1 in addition with that G. Elimination of feedback loop. In this, suppose the feedback loop is a positive one, the equivalent diagram having the transfer function G divided by 1 minus GH. If the feedback is negative, then the equivalent diagram has a transfer function G by 1 plus GH. So the rule is given in this slides. So by swapping two adjacent summing points having the same output. So in this example is given to find the transfer function of the following block diagram. Here we are going to move a loop from right side to left. So moving pickup point B behind block is given in this slide. While moving, we are going to use the set of rules given in this previous slides. And eliminating loop 3, we are getting like this. So using feedback rule, we are combining the block. We are combining the two blocks and getting the transfer function like this. While the transfer function T of S is equal to Y of S divided by R of S, that is output by input. So another example. Based on the rules, we are reducing the block diagrams. So the set of rules is important and how to use the rule in that block diagram reduction technique is important to reduce the block diagram as simple as possible. Thank you.